All right, so question number 81A. We're going to use the general solubility rules given in table 4.1. We're going to name 3 reagents that would form precipitates with each of the following ions in aqueous solution. Then we're going to write the net ionic equation for each of our suggestions. So for 81A, this is the chloride ion. Now, we're supposed to reference a table. Here's our table, table 4.1. Now what we should notice here is that most chloride ions are soluble. Notable exceptions are salts that contain the ions Ag, silver, Pb, 2+ there, lead, 2+, and Hg2, 2+, or mercury 1. I know it's kind of weird, but think about it, that's mercury 1, that's its oxidation number. All right, so the first reagent that we might look at is silver. Now, an example of a reagent that would include the silver ion would be silver nitrate. That's an example of a reagent that would precipitate a chloride ion. An example would be a silver ion that is aqueous in solution would combine with a chloride ion that is aqueous in solution. It would form silver chloride. All right. Another ion that we could use here would be the Pb. We could also use the acetate anion if we were really looking for a specific reagent. Oh, PbNO3, there's 2 of those. There you go. A net ionic equation would be our lead 2+ ions in solution would combine with 2 ambient chlorides in solution, and the result would be lead 2 chloride solid. The final one we might look at here would be mercury 1 nitrate. Now mercury 1 is a polyatomic cation that includes 2 mercury 1 ions that sum to a total oxidation number of 2+. So it is kind of awkward and strange, but hopefully you can get used to it if you think about it. So the Hg2 2+ ion, there you go, would combine with 2 chloride ions in solution. There you go. To form mercury 1 chloride as a precipitate. Now another question we were asked to look at here was number 84. So we've got a mixture. Now the total mass of the mixture is 1.45 grams. We're going to precipitate out all of the aluminum here with sodium hydroxide to make aluminum hydroxide. Then we're going to filter it all out and weigh the mass of our aluminum hydroxide product. Finally, we're solving for what is the mass percent of aluminum sulfate in our sample mixture, which was a 1.45 gram sample mixture. Now for number 84, one thing we just want to establish here is that, the mass of substrate A plus the mass substrate B adds up to 1.45 grams. Now this statement we don't really need for any calculation specifically, but we just want to get that in our head that there's 2 things in the mixture and they sum together to 1.45 grams. Now the precipitation reaction we had was any of the aluminum sulfate in solution would combine with the sodium hydroxide that we added in excess to form the precipitate aluminum hydroxide and sodium sulfate. We balance this all out. We get 2 here, put a 3 there, put a 6 there. All right, we're balanced. So we know the mass in question number 84 here. 0.1, where are we at here? 0.107 grams. Blech. Get the words out. 0.107 grams of aluminum hydroxide. That's what was recovered. So first step would be to convert that into moles of aluminum hydroxide from grams of aluminum hydroxide. And 1 mole is equal to about 78.004. The more digits you carry here, the less likely you are to have a rounding error later on. But since this has 3 significant digits and this has 5, I doubt that this will make a difference when we round our final answer. Now, once we convert grams into moles, our next step would be to solve for how many moles of aluminum sulfate. From our moles of aluminum hydroxide. We had 2 moles of aluminum hydroxide from every 1 mole of aluminum sulfate. Now, we want to know mass of aluminum sulfate. So of that mixture, how much of it was aluminum sulfate? And this one is about 342.17 grams. That'll cancel. All right. Now we do some calculating, and I think we finish off with 0.235 grams of aluminum sulfate was in our mixture. Now we were asked to do the mass percent. So that's 0.235 grams of aluminum sulfate in our 1.45 gram mixture. Times 100. And we end up with 16.2%. So in this mixture, 1.45 grams, 16.2% of it was aluminum sulfate.